Good morning, students. Welcome to Brilliant Public School. Topic of today's discussion is vector algebra. Prerequisite knowledge required is scalars. You have already learned that physical quantities which can be completely defined with magnitude alone are called as scalars. Examples are length, mass, distance, etc. You have already studied this in your 9th and 10th class. Vectors are the physical quantities which requires magnitude as well as direction for its complete description and are called as vectors. Examples for vectors are displacement, velocity, force, etc. So today for the topic vector algebra, the first thing which we are going to learn is directed line. A line with direction prescribed is called a directed line. A quantity that has magnitude as well as direction is called as vector that we have already studied in the earlier slide. Now the arrow on this line indicates the direction of the line, so this directed line becomes a vector. Now let us discuss what is position vector. In three-dimensional space, consider a point P with coordinates x, y and z. Using distance formula, we get that OP is the position vector with xi plus yj plus zk, and this vector is always denoted by r. Magnitude of this r is given by under root of x square plus y square plus z square. Now this position vector makes some angles with all the three axes respectively. Angle alpha, beta, gamma made by the position vector OP with x, y and z axis respectively are called as directional angles. The cosine of these directional angles is called as direction cosine. That is cos alpha, cos beta, cos gamma. They are called as direction cosines and are defined as cos alpha is equals to x by r, cos beta is equals to y by r and cos gamma is equals to z by r, where r is the magnitude of position vector and is defined as r is equals to xi plus yi plus zk. Now let us come to some important types of vectors. Co-initial vectors. Two or more vectors having the same initial point are called as co-initial vectors. Equal vectors. Two vectors having same magnitude and direction regardless of their initial points are called as equal vectors. Negative vectors. Two vectors having same magnitude but exactly opposite direction are called as negative vectors. Now let us come to the addition law of vectors, that is triangle law of vector addition. Now in the figure you can see AB represents a vector A and BC represents the vector B. Then if AC represents the vector C, then by triangle law of vector addition we have AB plus BC is equals to AC. That is vector A plus vector B is equals to vector C. Vector C is called as resultant of the two vectors A and B. Now we extend the triangle law to parallelogram law. If two vectors A and B represented by the two adjacent sides of the parallelogram in magnitude and direction as shown in the figure, then their sum A plus B is represented in magnitude and direction by the diagonals of parallelogram through their common point. This is known as the parallelogram law of vector addition. Now let us come to the components of the vector. In three-dimensional geometry as shown in the figure, let us take points on x, y and z axis as follows. That is A 1 0 0 on x axis, B 0 1 0 on y axis and C 0 0 1 on z axis. So we have OA is equals to 1, OB is equals to 1 and OC is equals to 1. These vectors OA, OB and OC, each having magnitude 1, are unit vectors along the axes OX, OY and OZ respectively. They are denoted by I, J and K as shown in the figure. Now, vector joining 2 points. Let us take any 2 points in the 3-dimensional space, that is P1 and P2 as shown in the figure. So here again we use the triangle law of addition and we get that vector P1 P2 is nothing but x2 minus x1i plus y2 minus y1j plus z2 minus z1k, and the magnitude of this vector P1 P2 is given by x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square and the under root of this entire quantity. You have learned section formula in your 10th class, but we have done it in 2-dimensional space. The same formula we extend in 3D with the knowledge of vectors. Now here, if I take point P and Q and R is the point dividing the segment PQ in the ratio M is to N. So, you can see MRQ is equals to NPR, where M and N are positive scalars. Then we can say that R divides PQ internally in the ratio M is to N. Now, from the triangles ORQ and OPR, we have RQ is equals to OQ minus OR, that is B minus R, and PR is equals to OR minus OP, that is R minus A. Now replacing the values, we get vector R is equals to MB plus NA upon M plus N. Hence the position vector formula of the point R, which divides PQ internally in the ratio M is to N, is OR is equals to MB plus NA upon M plus N. This is the internal division of the vector. Now here, if we talk about external division, from the figure you can very well see that we have extended the segment PQ till the point R, and now this PQ is divided in the ratio M is to N here. So in the similar manner, we get those two triangles, and using the section formula now, here we get it as MB is equals to M minus R plus NA. On simplifying, we would get that vector R is equals to MB minus NA upon M minus N. So, now let us take a close recap of all the concepts of this particular chapter, that is vector algebra. We have studied what is position vector, then triangle law of addition, parallelogram law of addition, components of vector, vector joining 2 points, and section formula, which was comprising of internal and external division. Thank you, children. Keep learning. Revise this property and solve the questions. Thank you, everyone.